Okay, so we're going to look at operations on polynomials. And so the first thing we're going to do is add polynomials, and the big idea here is just to remember to combine like terms. And so all we're going to do is add their coefficients. So we've got an 8x here and a 2x. And then we've got a 5 and we've got a -1. Those are our constants. And then we've got a -3x squared and 7x squared. And so those two, all of those things, we're going to add their coefficients. And we're going to start with the biggest exponent. So we've got -3x squared and 7x squared. Those two go together. And so that leaves us with a 4x squared. And then we've got the x's. So we've got 8x and 2x. And so we've got 10x. And then we've got our constants, 5 and -1. Okay, and so if we look at the next example, it's the same thing. We're adding, we're combining like terms. And so first we've got a 3xy to the 4th. And then so we're looking with anything else that has those same variables and exponents. So x to the 4th, y to the 4th, we've got 1 down here. And then we'll look at the next one, 8x to the 4th and 8x to the 4th. So since we've got that plus in between them, we know that there's no extra steps that need to be taken. And so then lastly, we've got an xy to the 3rd. We've got 6 of them first, and then we've got -8 of them next. So when we combine like terms, we'll do it according to the biggest degree of the x. And so we've got 3x to the 4th, y to the 4th, and -3x to the 4th, y to the 4th. So 3 minus 1 is 2. Then we've got 8x to the 4th and an 8x to the 4th. So that means that we've got, I accidentally turned on the eraser, 16x to the 4th. And then we've got 6xy to the 3rd and -8xy to the 3rd, which gives me a -2xy to the 3rd. So that's adding. Subtracting is basically combining like terms, but we have an additional step. All we have to do is remember to distribute the negative. So adding and subtracting are both pretty easy, but you have to be really careful that you don't add when you're supposed to subtract and you don't subtract when you're supposed to add. So just be really, really careful with your signs. So in this example 3, notice that you've got that minus sign in between. You would think, I would never make that mistake, but really, it's easy to do. So we've got that minus in between, and so we're going to distribute the negative. Technically speaking, we're distributing a -1. And so I like to rewrite everything. And so when I distribute that negative, it flips the sign of everything inside the parentheses. And once I've done that, I'm going to combine like terms, just like we did when we were adding. And lastly, the 2 and the 8. And so when I combine like terms, I'm just going to add them together. So 7a minus 3a is a 4a. Minus 10b and a minus 4b is a minus 14b, and then 2 and 8 gives me 10. And this next one, we've got function notation, and all that does is it's naming a polynomial. So instead of it being in sets of parentheses, it's just being named as a function. So this first one is g of m. So if g of m is 5m cubed minus 3m squared minus 1, and h of m is 2m squared minus 3m cubed minus 4m, find h of m minus g of m. So this last piece right here, h of m minus g of m, just tells me that instead of rewriting out all of those numbers again, we're just using their names. It's just kind of a shorthand. So we'll start with h of m, which is 2m squared minus 3m cubed minus 4m, and we are subtracting g of m. So now that we have written it out, it looks just like our example in number 3. And so we want to distribute the negative first. And so I like to rewrite it all out. When we distribute that negative, all it does is flip the sign of everything in there. And then we'll combine like terms. So 2m squared and 3m squared go together. Negative 3m cubed and negative 5m cubed go together. And the negative 4m doesn't have anything that it combines with, and that constant 1 doesn't have anything either. So that's really all we can combine. So we'll start with the biggest exponent, which is to the third, and so we'll have a minus 8m to the third. 2m squared plus 3m squared gives me 5m squared minus 4m, which combined with nothing, and the 1 that combined with nothing. In example 5, we've got 3 different sets of parentheses with lots of things. So we do have addition, but we also have subtraction, so we do want to go ahead and distribute that negative first. And so I'm going to rewrite everything out. So I've got it all in one log big mathematical sentence. When I get to the distributing the negative, all it does is flip the sign of everything inside the parentheses that follow, and then I'll combine like terms. So 5x to the fourth and a minus 3x to the fourth go together. The 3x to the third and the 2x to the third go together, and the negative 8x to the third, so that one had 3 terms. The 10x squared and the negative 4x squared, and then the 7 is a constant, and it doesn't have anything that it combines with. So when we write our final answer, we want it to be in descending order, so we'll start with the highest exponent, which is a 4. So 5x to the fourth minus 3x to the fourth is a 2x to the fourth. And then we've got 3x cubed plus 2x cubed minus 8x cubed. So we've got a negative 3. And then we've got 10x squared minus 4x squared, which gives me a 6x squared. We don't have any just x's, no linear terms, and so we'll go ahead and add the 7. So this next section is the you try section. So I'm going to write on the screen, but I'm not going to comment while I do it. So you can be working while I work, and then you can pause it and see if we got the same thing. But I'm not going to comment about it. So I'm going to start working on number 1. You can start working on number 1. So there's number 1. You know what I did? I just made a mistake that I told you guys not to do. I subtracted when you were supposed to add. Let me go back and do number 1. Easier than you think to mess up. I keep erasing. Okay, that should be right now. All right, and then I'll go to number 2 now. All right, so for number 2, your final answer should be here. Order doesn't matter, especially since we have so many variables. So make sure that you can get those, and if you have any questions about adding or subtracting, feel free to email me. All right, so last thing we're going to look at is multiplication. And so with multiplication, sometimes you'll have a monomial, which is 1 term, or a binomial, which is 2 terms, or a trinomial, which is 3 terms, or even a polynomial that is 4 or more. So sometimes it can get really, really complicated. But multiplication, once you multiply, you do want to make sure you don't have any like terms. You want it as simplified as possible. So this first one, we're going to distribute. All multiplication is just a fancy way of distributing. And so if you've got the same base, you'll multiply. And so we've got 2x to the 4th y times 4x squared y squared. So same base, add exponents. That's a product rule. It's an exponent rule. So 2 times 4 is 8. X to the 4th times x squared, same base, add exponent. So 4 and 2 is 6. And then y times y squared. If there's no exponent, we assume that there's a 1. And then we'll distribute 2x to the 4th y times 3xy, so we'll add 6x. X to the 4th times x would be x to the 5th, and then y times y is y squared. Remember, if there's nothing there, we assume there's a 1. And then we'll have 2x to the 4th y times 9. So only thing that multiplies there is the number. So 2 times 9 is 18, and we keep the x to the 4th y. So example 7 combines some things. We've got multiplication and we've got subtraction. So first things first, we'll multiply. So we've got 4x squared times 4x cubed. So we've got 16x to the 5th. Remember, same base, add exponents. 4x squared times a negative 2x. Remember, if there's no exponent, we assume it's a 1. So 4 times negative 2 is a negative 8. And then x squared times x would be x to the 3rd. And then 4x squared times negative 8, only thing they have in common is the number. So we'll have a negative 32x squared. And then in the next one, we've got some subtraction. So we want to go ahead and distribute that negative all in there. So we'll have opposite signs of everything. So negative x cubed plus 3x squared. And then all we have to do is combine like terms. And so my final answer is 16x to the 5th minus 9x cubed minus 29x squared. Okay, so if we have binomials, those get tricky because it's very easy to forget about their middle terms. So there's 2 methods we're going to look at, the FOIL method and the box method. Once you have done them both in notes, I don't care what you do on homework as long as you are doing one of the 2. So in example 8, we are going to use FOIL method first. So that stands for first, outer, inner, and last. And so my first terms are x and x. They're the first terms in both sets of parentheses. My outer terms are in the outside, so all the way to the left, all the way to the right, so x times negative 3. My inner terms are the 4 and the x, and that's where the parentheses are touching, so 4x. And then 4 and negative 3 are both the last terms in each binomial, so you've got a negative 12. And then we'll just add like terms, so that 3x and 4x go together. Oh, minus 12. Sometimes it's easier just to do the box method. It's more visual, it's easier to see, and you don't forget as much. All right, and so anytime that your columns and rows intersect is what you're going to multiply. And so just make sure the 4x plus 5 are in the same set of parentheses, so they need to be on the same side of the box. So top left, we've got 4x times 2x, which is 8x squared. 2x times 5 is a 10x. 4x times negative 2 is a negative 8x. And 5 times negative 2 is negative 10. The really cool thing about using the box method is that your like terms will always be diagonal. So my final answer here would be 8x squared plus 2x minus 10. Another notation you might see is x minus 4 squared. So that doesn't mean just square the x and just square the negative 4. Since it's a binomial, you've got to make sure that you're multiplying everything by everything. So that's saying x minus 4 is occurring twice. So it's multiplied by itself. So if we use the box, we'll have x minus 4 times x minus 4. And so where they overlap is where we'll multiply. And so my final answer there would be x squared minus 8x plus 16. So example 11, we're getting a little more complicated. So it's just to set us up for the future when we start talking about vertex form and when we talk about quadratic formula and all sorts of good stuff. And we're going to simplify the expression so that it looks like ax squared plus bx plus c. And so all we're going to do is follow order of operations. So we'll take care of parentheses and exponents and then multiplication, division, addition, subtraction. So first things first, my parentheses and exponents are kind of in the same set. We've got x plus 5 squared, which just looks like example 10. So over here, we're going to multiply x plus 5 times itself. So I like the box method, but if you can FOIL or if you can do it mentally, go for it. And so what we're going to do once we've multiplied that out is we're going to substitute it back in. So we're going to keep the 2 in the very front, but x plus 5 squared is now x squared plus 10x plus 25, and we're going to keep that minus 7 at the end as well. So we've taken care of the parentheses and the exponents. Now we're going to multiply. We've got multiplication. We've got distribution that needs to happen. And so we've got 2x squared, 2 times 10x is 20x, and 2 times 25 is 50. And we'll keep that minus 7. Don't distribute the 2 all the way to the negative 7. It's not in the parentheses. It's not in that set. And then we'll just combine like terms. So that 50 and minus 7 are the only like terms that we've got. And that's the end of that one. So sometimes it gets a little more complicated. You've got 3 binomials. Multiplication is commutative, so it doesn't matter what order you multiply. So this one, for example, 12, we've got 3 binomials. And so all we're going to do is take it one step at a time. So first, what we're going to do is multiply the first 2 binomials. So x minus 6 times x plus 4. And once we get that product, we'll multiply it by the x plus 2. You could draw all these foils and lines and all this stuff to distribute, but that gets really complicated and typically you'll make a mistake somewhere. At least I will. So we'll just do it this way. So when I multiply those first 2, I get an x squared minus 2x after I combine those like terms minus 24. And I'm going to multiply it by that last binomial that I got. So x plus 2. And then we'll just multiply one more time. So same concept, rows and columns where they overlap, they will go together, multiply together. And if I have like terms, they will be diagonal from each other. So there we go. All right, and so finally, my final answer will be x cubed. My 2x squared minus 2x squared cancel each other out, so I don't have that term anymore. Minus 28x minus 48. And so these last 2 at the bottom, they're mixed review. I'm going to go ahead and work them out silently, and you can pause your video here and see if you can figure them out. They're kind of challenge problems just to see how well you do. And then once you finish that, you can go ahead and work on your homework. So So I'm going to work these out. So first thing I did was multiply that x plus 1 squared, and then I replaced it in. Then I'll distribute the -3. And then I'll combine like terms. I think those are fun. All right, last one. I've got a 3 by 3 box because I've got that many terms. And like I said, these are challenge problems, so if you can do these, everything else should be a piece of cake. Can I squeeze it in? So there's your answer for that one. Hopefully, did that pretty quick. Hopefully I didn't make any mistakes. So now that you have done